All right, today we're going to go over exponents, the properties of them, and how we simplify problems that have exponents in them. So we're going to go over some of the background information, then we're going to jump right into some examples. Okay, here's the properties, and I'll attach a PDF of this on Google Classroom as well, but there's some things that I want you to add to this, so it's not so simple. Okay, so this first example, I have x to the a times x to the b, and that equals a plus b. So multiplying, so when you're multiplying two terms that have exponents in them, you're going to add the exponents together. Okay, the next one is going to be dividing equals subtract. So if you have two like terms that have exponents in the top and bottom of a fraction, you're going to subtract them. Okay, the next one, raised to a power equals multiply. The next one, anything to power 0 equals 1. So literally any number, any variable to the power of 0 is going to equal 1. Numbers 5 and 6, when you have negative exponents, move them. So in number 5, the negative exponent was on top, so it needed to be moved down to the bottom to be positive. In number 6, the negative exponent was in the bottom, so it needed to be moved to the top in order to be made positive. Okay, the next one, just make sure if you have multiple terms in parentheses, distribute the exponents to everything. Okay, so like I said, in number 7, 8, and 9, they all have terms inside of parentheses with an exponent on the outside. So the most important thing is to distribute exponents. So if there's an exponent on the outside, it goes to every single term that's on the inside. I know this is a lot of information, way too much information, but you've got to have these down before we can get into the actual examples, because these are a lot of rules that you have to apply in one problem. Okay, so this is what your homework is going to look like. We're going to do a few of these together. We're going to start with number 1. We have 2a cubed times 5a to the 4th. So this is a problem. I need it to be simplified. Right now it's not simplified. There's multiple a's, multiple coefficients. I need there to be one coefficient and one a term. All right, so first thing I always do is look for my coefficients. The rules for exponents are rules for exponents. They are not rules for regular numbers. So 2 times 5 is just going to be regular. That's 10. Okay, now I need to look at my exponent rules and figure out how I put these a terms together. So right now they're being multiplied. So what do I need to do with the exponents? Well, the rules say when I'm multiplying, I need to add the exponents. So 3 plus 4 is 7. So my answer for number 1 is 10a to the 7th. Okay, next one, I have 3x squared y cubed, all of that's in parentheses, raised to the 2nd power. So before I can do any simplifying at all, I've got to get rid of the parentheses and the squared on the outside. So we just went over steps 7, 8, and 9, that when we've got a number on the outside, it's got to be distributed to everything. So it comes to the 3, the x, and the y. Okay, so this is going to become 3 squared. In our rules for exponent, it says you multiply the two numbers together. So 2 times 2 is 4. And for the y's, 3 times 2 is 6. Okay, now this looks like it's pretty close to being done. The only thing is I can't have 3 squared. because that's an actual number. So you can put that into your calculator, 3 squared, and you should get 9. And then there's only one x term and only one y term, so that means that this problem is done. Next example, I have in parentheses 6x cubed raised to the 0 power over 3xy squared. Okay, so I remember from my rule sheet that there was some sort of a rule about being raised to the 0 power. So go back to that. Anything raised to the 0 power is what? 1. So the whole top becomes 1 because the 6x cubed is all being raised to the 0 power. And that's all over 3xy squared. Okay, now I need to figure out, is this problem done or not? I've only got one x term, one y term, and I've only got one regular number as well because 1 over 3 is 1/3. Nothing can be reduced or anything like that. So that means that this problem is finished. All right, next example. This one's a little bit more involved. So I have 3r to the negative second, s cubed, t to the 0. All of that's being raised to the negative third power over 3rs. Okay, so first thing I would do is take this negative 3 and distribute it. So then I'm going to have 3 to the negative 3, r, what's negative 2 times negative 3? 6. S, 3 times negative 3 is negative 9. 0 times negative 3 is 0 over 3rs. Okay, now we need to do some simplifying here. So remember, when there's no exponents written, all of those exponents are 1. So I've got terms on the top, terms on the bottom that can be put together. When they're being divided, we need to subtract. So negative 3 minus 1 would be 3 to the negative 4. Okay, for r, 6 minus 1 is 5. And for s, negative 9 minus 1 is negative 10. And t to the 0, what did we say anything to the 0 power was? We said it was 1. So I can just cross that off because that means the whole top is being multiplied by 1, which doesn't change anything. Alright, so it looks like I'm kind of getting close, but still not there yet. I've got some negative exponents. Remember when we talked about negative exponents, if they're on top, they can be moved to the bottom. That means this is going to be sent down, and so is the s term. I'm not going to touch r because that is already positive, which is what we want. So I'm going to have r to the 5th on top, and then these exponents are going to turn positive. So 3 to the 4th, s to the 10th. Okay, but remember, 3 to the 4th, that can be put in your calculator. So you want to do 3 to the 4th power, and that's going to be 81. So my final answer is going to be r to the 5th over 81 s to the 10th. And all your work for this week can be found on Google Classroom.